All right, welcome back to Meteorology 101. We're going to jump into these storms. I'm going to pull the latest surface chart. Let's see what happened with this low pressure system. And then we'll jump over to the radar. We'll jump into the storms and just to kind of track, see what's going on there. So we'll pull up some soundings too. We'll look at our stability, see how anything's changed. I'm going to put the sea level pressure on this chart, and then I'm going to put the station plot so we can verify where our highs and lows are. We got that low pressure system. It moved over Texas. It was up around the four corners. It's dropped down south, moving pretty quick into Texas, and then that was an inverted trough all the way up through Missouri, Illinois. Now that low pressure system is broken off right over the Ohio Valley we were talking about last night. So with our surface plots, the observations, we can tell what our wind directions are and verify these highs and lows, and then we'll put some isotherms on here, and that will show us our thermal advection. So right now we got surface winds about 15 knots in Alabama, 20 knots in Tennessee, 25 knots in eastern Tennessee around the mountain range, and then shifting southeasterly. Looks like only 5 knots, some 5 knot winds variable through Indiana, Illinois, wrapping around that low, and then 10 knot winds, 10 to 15 knots, kind of wrapping around the low pressure system in Texas. I'd probably move that low maybe a little bit further east, just based on looking at this wind direction, or maybe even put it a little bit further north. So maybe a little bit further to the northeast. But when you get 5 knot winds, that can just be any kind of variable wind. So the observer or the ASOS would pick up a 5 knot sustained at that time. So they can be wherever them winds were at the most of the time is where the ASOS puts that out. So 5 knot winds I don't really pay too much attention to. We look at 10 knot winds or greater. But look at the ceilings. We got the red for IFR conditions, blue marginal VFR. So we got a lot lower ceilings. We got ceilings at 400 feet, 800 feet, 400 feet, right around Missouri, Indiana, Ohio. Let me pull up my drawing tool here so we can start drawing on the screen here. Let's look at try to get an idea if we definitely got severe weather threats all through Kentucky, Tennessee, all the way into Alabama, so Mississippi. So but most of our energy was in the further south, even down into Louisiana. So if we look at this, we got 10 knot winds. Out of the south, 15 knot, 15 knot, pushing up. So we should have some pretty good thermal advection. Let's go see what kind of thermal advection we got real quick. Let me get rid of this. We go put some isotherms up here. Alright, so we do have a pretty tight thermal gradient. All these isotherms, this is Celsius too. It's every 2 degrees Celsius. That gets a lot less cluttered than the Fahrenheit. That's why I use Celsius on this. But we have a real tight thermal gradient. But the problem is we don't have much thermal ridging going on. Very slight thermal ridging in this area. Nothing to cause any major severe weather that we're looking for. I mean, we're getting severe weather warnings in these areas. But how severe is this going to be? I would say mostly if we get anything in Kentucky, Tennessee, I'm looking at mostly rain damage, wind damage, and heavy rain. So let's go to the radar real quick, pull up that local area. Now we see right now there are no tornado warnings. All tornado warnings are expired. There was radar indicated warnings. So let's back this off a little bit. We got a 3-inch wind report to the west. We got a couple severe warnings still in effect. There's 4 of them. 1 in Tennessee, 3 in Kentucky. We got Hickman, Maury, Williamson counties. Adair, Casey, Greene, Marion, Taylor, that's a warning for those counties. Lewis County, and Barron and Metcalfe County. And then flash flood warnings in Christian and Todd County, Kentucky. So the Hickman, Maury, and Williamson, that's in Tennessee. So there's our, get rid of this cross section. Hold on just a second. Right there's our warning in Tennessee. Here's our warnings through Kentucky for our severe thunderstorm warnings. We did have some tornado warnings right around this area, just north of Columbia. So you are getting some pretty heavy rain in that area. We got high reflectivities right around 67 dBz. So we can pull a cross section on that. Let's see how severe this stuff is. We get to the point. I'll have to back up a hair just so we can get which screenshot we need. So we got some tilt on that storm. High reflectivity is up to 20,000 feet. So that justifies the severe warning. Let me get where you guys can see this thing. Alright, there's the cross section. Okay, so we got that 60 plus dBz's in the upper level, so that looks like a hail maker. There's a little bit of hail in that area. I didn't see anything on the radar indicating that. Let me turn that on. Okay, so now we got 0.6 inches of hail, less than 3/4 of an inch. So we did, with the reflectivities in the upper levels, we did justify this severe warning. Now if we do a volume scan on this storm, right now we don't see anything. Let me go to change my reflectivities. That's mostly low reflectivities in that area. Let me back up. I'm gonna have to go. This volume scan's not picking up this latest shot, so we gotta back up a hair to that one. So now we got that higher reflectivities in the center of the scan. So now we can drop this to raise up to 60 dBz, 50 dBz. That's our significant area. We do have, like I said, we had some tilt in that storm. We can go back. We can look at rotation. Mostly looks like we got a lot of horizontal rotation, but it's kind of starting to go vertical a little bit. So I'm surprised they don't have any kind of tornado warning right there. They were throwing tornado warnings all over that earlier, and we weren't even this significant on the rotation. So look at the base velocity. We do have some rotation in the upper levels right there, just from very small areas. Bring this down. So I'm not seeing that major formation. So like I said, no warnings, just severe in that area. No tornado warnings. That tornado warning has expired. Let's go to this cell around Greensburg. Just went out of Greensburg, headed for Campbellsville. Let's play the loop on this real fast so we can see where it's headed to. One headed past north of Campbellsville. Another one just missed Campbellsville. Here's the latest one coming up. Greenville, just staying south of Campbellsville. Elkhorn might get hit with that one. So let's get to the latest shot, and then we can pull a cross section of that one. So I got to basically back up a couple shots to get a good read on that one. Go down here. There's that tornado warning that popped up. That was only a couple shots ago. Let me get this cross section in the right spot. So we got higher reflectivities up to 10,000 feet, 50 dBz, so that justifies severe. We got a little bit of tilt on the storm. But I'm not looking at like any major supercells right now. We're strictly in severe weather, not tornado warnings. So And if we do a 3D scan, let's go smaller so we can get zoomed in on this thing a little bit. No major structures. Let me get go to some lower DBZ. We can see the upper levels of the storm with the lower reflectivities. So even this thing is just with the lowest reflectivities, we're only just over 20,000 feet. So we got a little bit of overshooting tops in that area, but we're not nothing real significant on this storm either. So we'll go back to between 40 and 50 dBz, and then we can pull up some rotation too and see what we got here. So we do got a little bit of rotation in that storm. So these are just a couple of storms to keep an eye on. They do have the highest reflectivities, a little bit of curvature to them. Let's zoom out. And let me get rid of that. Drag the screen around. Pull up another radar. So like I said, here's the storms with the highest reflectivity. They're just calling them straight out severe right away. Here's a couple reports. Fire department and rescue, flash flooding. This is near 1 mile northwest of Middlesburg. And then we have one in Liberty. Casey, Kentucky, fire department rescue for a flash flood. So you watched my video from last night. We just got 2 tornado warnings just popped up, but from last night we were talking about most of this stuff being flash flood, severe warnings. Not really looking at. They even got a tornado warning here. Let's see what's going on. 2 tornado warnings just popped up. So let me get another radar shot at this thing. Maybe we can find out why they're going severe on these, or tornado warnings on these. Maybe some rotation indicated by radar. We'll pull up radar indicated rotation. Look out for flying debris. So let's do a volume scan in that area. Look at the rotation. I don't see a lot of rotation in that. We're looking for them greens and blues to kind of push up against each other for any kind of major horizontal or vertical rotation. I mean, once you go vertical, that's when you start getting the vortex, but this is pretty weak right now. Cross section. 50 dBz's at 10,000 feet. I mean, it gives you severe potential. Base velocity. I'd see more rotation just to the north of that warning area. It's going to the upper levels. See, it's still to the north. If we go to the higher elevations of the radar, I'm not seeing anything in the warning area. Let's go to the next one. Actually, there's one down here. Pull up this radar. Thunderstorms being reported in that area right now. Download the loop. This warning there is just over Centerville, Fairview. Alright, so my base reflectivity. Okay, we do have a hail indicated by radar just over 1/2 inch. Go do a cross section on that one. Good tilt on that storm. High DBZ's up to 20,000 feet. We do got some tilt. Let's go base velocity. I don't see any real rotation in that cell though. Let's do a 3D scan on it. Back up off that just a little bit. Like I said, we got pretty good tilt of that storm. Let's look at some rotation. I don't really see the real significance of rotation right there. Let's do a base velocity. Hold on just a second. Alright, so I'm getting interrupted there, so I had to pause the video for a second. Like I said, this is the base velocity in 3D. I'm not seeing a whole lot of rotation in this storm. Pull it down to the lower levels. See if we can get it red in there. It does have some pretty good structure to it though, so I would I think it would justify that tornado warning, so get rid of that. So that's pretty much justifying that tornado warning. It does have the structure, it does have the tilt, so that's the only tornado warning left right now. We got looks like 4 severe warnings, but I want to shoot down to Mississippi, Alabama. We finally got a severe warning in Mississippi. This is the area we were looking for. If any tornadoes would happen, be in that tri-state area. So I want to see, get this radar downloaded here. See if we get supercells scattering like the HRRR was showing. Just scattered supercells all through this area. Our dew points are 64, 66, 70. So we got the dew points for severe weather in that area. We got 25 knot winds, warm air advection. The stability indices is what I was more concerned about. That we just didn't have the stability indices, the CAPE, the energy, to really produce a lot of tornadoes in this area just based off that. But based off the low level jet, the moisture, the dew points, the warm air advection, we did have, you know, all the criteria we need for severe weather. But for the energy that was needed, that just really wasn't present. So I'm having some trouble downloading this data for some reason. It's taking a while. Go to another radar. Try this one. See if we can pick something up on this storm, this severe storm. So it's located, severe thunderstorm located near Burton. So moving east at 55 miles per hour, 60 mile per hour wind gusts, and penny-sized hail was that hazard, and the source was radar indicated. Alright, we're not getting anything there. We're not reaching out that far. Let's go down here. There we go. One isolated cell. Alright, let's do a cross section on this thing. See what we can pick up. We do have tilt on that. High reflectivity is 10,000 feet, so that justifies the severity of the storm. I don't see any hail indicated by radar. Get that turned on, so it's not showing anything there. Let's do a volume scan on this one. That's cross section. I'm going to go volume scan. Okay. Let me get a little bit to the west on that one. Alright, so we do got some tilt on that storm, so justify the severity of it. We're at base velocity, see what kind of structure we have here. A little bit of rotation in the lower levels. Good structure on it. So that may be a supercell developing right now. May go into a tornado warning right there. Pull that up again. I want to see rotation. Really not a big indication of rotation there. Go to the higher reflectivities. 50 dBz. Like I said, it does have pretty good structure on that storm though, so. That's our first warning in the Mississippi. Let's go back up. We're already in this tornado warning in Tennessee. Let's go look at that one again. Let's go pull some soundings. I'm gonna see what kind of stability we got. We got right there in Tennessee. Let's go Knoxville area. See what we got for our soundings. Let me open a new sounding. This is for Nashville. Alright, we got some pretty good cape in the upper levels, but we only have 242 joules, so we're not doing that great on energy. So some other readings to look at are sweat index. That's another stability index we can look at, and that's 167. I think we're looking at what we really need to be there is like for typically you're about 300 for severe storms. Tornado wind gusts showing 28 miles per hour. 1-inch hail could be produced in this area. 1.16 inches of water. Our LCL is 1,096 feet, so that's good for severe weather. You want a low LCL. 5,000 feet for the CCL, which we're not really concerned about that. We're not getting any convective condensation level. Daytime heating, we're looking at more of the lift because of that warm air advection in the frontal system going through. Level of free convection is 8,568. That's a little high. So it's going to have to hit 8,000 feet, push it to 8,000 feet before it can continue to, convection can continue above that level. Tropical pause. The tropical level was at 42,000 feet, so the highest that storm goes is about 42,000 before it hits the tropopause, and then you have the overshooting tops at that level, and then freezing levels at 10,600 feet. So that's a little bit high too. But if you go 30,000 feet, then you can definitely get a hail maker out of this too, with the 10,000 feet. So that's not too hateful. Total index is at 43. So we want to be, that's just a general thunderstorm area. We want to be for moderate thunderstorms 51 to 55, 55 to 59 for severe or strong storms, and then scattered severe storms 60 plus for tornado. So it'll be 60 plus on that one. The LI is a minus 2.4. So that one, thunderstorms possible, good trigger mechanism needed. And then -3 to -5, you have unstable thunderstorms possible. And if it's less than -5, it's very unstable, and you'll have a heavier, strong thunderstorm potential at that point. So that could be a lot higher. All these stability indicators could be a heck of a lot higher to be give us any tornadoes in that area. So they're going by tornado or radar indicated rotation. So that's what they're putting all these tornado warnings out there for. But in reality, The environment just doesn't have the instability it needs to do that. This is more for severe weather, and they always have to use the precautions when you got radar indicated rotation. You have to put the tornado warning out there. It just has to be done. So, all right, let's play the loop on this. Doesn't look like we downloaded too much of a loop, so. But you do have some pretty heavy rain. Surprised I don't have any flood warnings, more flood warnings than they do out here. So Lebanon, you're getting ready to get hit. Just went through Nashville, so Brentwood, Waterton, Lafayette. So we're still in. We got 4 severe weather warnings right now and 1 flood warning in Kentucky. There's a flood warning in Kentucky. That most of that looks like that's pushed out. I can pull up that radar. Sometimes it takes a little bit of time to download these, so let's see what we got. All right, here's a report for thunderstorm wind damage. 2 miles south-southwest of Goodlettsville, Davidson County, Tennessee. Trees down near Moss Trail and Garrett Drive. So if you live in that area, expect some trees down. This all looks like isolated stuff now, so that flood warning, they could last well after it rains. You still got a lot of water running across the streets and stuff, so a lot of rainfall in these areas. Let's go looking for more tornado warnings in this tri-state area. Thunderstorm warnings, like I said, wouldn't be surprised if this severe warning down in Mississippi didn't turn into a tornado warning. We had some pretty good tilt and reflectivities on that one. Alright, let's go back to our charts real quick. Let's look up some stability charts, stuff like that. We know we got that low pressure system over the Ohio Valley. Low ceilings. We got warm air advection right around that low. We got the warm air advection to the south, but the winds are too high for any fog or major visibility reduction. That would be caused by any weather itself, like rain, heavy rain, moderate rain, stuff like that. But when you get ahead of that warm front, like this low pressure forming up, that's where you get the lowest ceilings, because the warm front typically is a stable environment. But if you're in a unstable environment and you get that frontal system going through, even if it's a stable area, warm front, then that's going to give you your lift to cause all the convection. So let's go run another chart here. A couple more charts. Let's see what we got. Let's run a thickness chart real quick. This will help us place our fronts, jet stream. Well, I needed to erase that first, so that's not going to work out for us. We'll have to redo this one. Alright, start the thickness chart. There's our 540 line, well to the north. So that's the rain snow line. It's actually south of the Ohio Valley. So typically, if you get any precip in that area, it should be snow. But that's not the case. So this, I would say, this is right away inaccurate. We are definitely going to be getting some colder air in the Ohio Valley after this frontal passage. Once this low pressure pushes out of the way, that high pressure pushes in. You see the tight thermal gradient. So let's go right across these isotherms. So high pressure clockwise around the high. So cold air advection in this area. All through here. So it gets pretty weak right there. Then strong over here. There's our area of cold air advection. So as that pushes in, our temperatures are going to drop significantly. So if we look at these temperatures back here right now associated with that high pressure system and that cold air advection, right now we're in the teens, 16, 3, 15, so 37. So we may or may not get that cold in the Ohio Valley. That might be pretty modified by the time it gets to us. But we got, right now, there's a 37. So I would look for probably at least there's a 34 in the 30s in the next day or so after that frontal passage for the Ohio Valley. So with this cold air advection being pushed through, have to almost bring this cold front pretty much right back through here. It's kind of hard to analyze this stuff when you get this other low pressure system, because you almost want to go like warm air on the east side of that low, and then the cold front would almost just kind of drop down and join it. That'd be the only way to really pull that off. Now, really it would be like a, without any major thermal advection, but we do have some, it'd be weak thermal advection, so it'd be more warm front here. I put it right above that station with the winds out of the south, even right through here, and then bring the cold front down. There's our south westerly flow. There's a northerly flow. You're almost going to want to bring it right through there. So that'd be like the leading edge of this cold air mass on this high pressure system. Then we winds out of the south over here to the east of that low. Winds out of the south here, winds out of the north here. So we do got our kind of our rotation right there to justify that low. And then warm air advection. I don't really see any. Here's a thickness there. I don't see a whole lot of warm air advection in that area ahead of that low pressure system right there. So it's not real well developed yet. It just broke off. It's not really getting spun up just yet. It should, and then that's what's going to cause all of our instability through Kentucky, Tennessee, and give us that flooding, and then all the stuff to the south if we get this warm air advection from the south, causing instability in northern Alabama, Mississippi, and giving us our potential for supercells down there. Well, like I said, the stability indices just aren't really there for that, but you basically got to take all the pros and cons and weigh them all out and then find out, if that's possible. So I would look for, with this pressure gradient, that's pretty good thermal gradient. I would look for rain, winds, any kind of rain and winds mostly, and possible severe storms with hail, wind damage in Kentucky throughout Tennessee. That's on the thickness chart. We got the jet stream. We're going to put the jet stream right there in the middle of that, the tightest thickness packing. That's going to be where your jet is. We got the trough off to the east. We got ridging to the west, and that's another thing hindering a lot of this weather too, is with the upper level ridge hindering that, and then high pressure pushing into, starting to fill these lows or push them out of the way. So we got a lot of stuff hindering this system. Sometimes I think people get a little carried away with the low pressure, the warm air advection, the dew points being over 60 to 65. Then, they get carried away and want to call supercells right away. I mean, there is definitely potential here. I'm not saying it's not going to happen, but there's several factors hindering this too. Let's get back to the radar. There's isolated cell. So we do have some isolated stuff popping up in Mississippi right now. Isolated cell right here in northwest Alabama. Some isolated cells through Alabama. So we're kind of lining up with those storms for what the HRRR were showing. But how severe are these things? We're not in a severe warning just yet with these, but let's see what see if we can do a cross section. We got some pretty good reflectivities from those storms. So above 10,000 feet, so that would justify at least a severe warning if they went with one. Base velocity, a little bit of rotation in the lower levels on that one. So let's pull up the base velocity on this storm. Right there in that storm, a little bit of rotation. Not calling anything severe yet. Not calling any tornado warnings yet on this one. Our echo tops, 31,000 feet. So that storm's built up pretty good. The vertical integrated liquid isn't real far up there, so maybe that's why they're not going severe just yet. Let's do a scan on this thing. Get a better look at that. So we got 50 dBZs above 10,000 feet. I mean, they would justify going severe with this thing, but I don't see any major vertical structure. Try to get zoomed in here a little bit better. Our highest levels were to the north. We're to the south right now, so any rotation in this one might be horizontal. Looks like mostly wood is horizontal. Some areas through that storm with rotation, so that's definitely a good indication for that storm building up. There's a reflectivity. There's a velocity. Bring this down. Try to see what kind of structure we have with that. Right above that area of rotation. That's where our strongest velocities are. Not a real great structure. But definitely a improvement starting to build up in the middle of the storm too. So that could turn into something there. So Algoma, I don't know what that is. Pontotoc. I'd keep an eye out on that storm. Watch for that to possibly go at least go severe. So what kind of loop we have here? It's definitely showing it is increasing in intensity. That severe storm's gone. So northwest Alabama, it's got the isolated cell. Let's see what we got there. It's still pretty impressive. I mean, wouldn't be surprised if that one didn't do something too. Let me go see the structure of this thing. We got pretty decent structure there. But we didn't see, let's go base velocity, see if we see rotation on the surface. Really nothing there. See, I'm in the upper levels. Let me drop back down. So there we go. I didn't want to do that. Alright, let's go back to this storm. I was in the upper levels on that. Get back over here. I'll go base velocity. I mean, we can see kind of rotation all through this area. So that is the area where that severe Well, it ain't even severe yet. They haven't even listed this severe. I would expect that to go severe any minute. So right now our time is 1924 Z. So we got some pretty good cells still popping up to the south. Let's go. It's all in Mississippi, a little bit in Alabama, up into Tennessee. Most of our severe stuff's to the north. Um, Down trees, we already called that one out. Look up Paducah's radar. Here's a 1.66 inches heavy rain, White, Illinois, by a train spotter. That is the storm total rainfall so far. So like I said, you're probably going to see a lot more flood warnings come up. I would suspect pretty much severe weather all through that area. Let's go look at let's go look at the national radar real quick. Show you how widespread this is. We're shooting radar to radar, and it's hard to get that big picture. All right, there's the loop for the national radar. You can see we got some snow up through Iowa, northern Illinois, stretching all the way back into Colorado. Mixture right there on the line, and then all this rain. So here's our isolated stuff out in the front of that frontal system, stretching from the low pressure system over the Ohio Valley, that front dropping down into Texas, and then all that lift instability in that warm sector from all that warm air advection off the Gulf, starting to build up these cells right here in Mississippi, Alabama, and Tennessee. So like I said, we're going to probably see just severe warnings all along that line, and then flood warnings all around this area. So I just zoomed in on a section. I was trying to get that screen live where you can see my hand pointing. Alright, here we go. So right there's the line. Like I said, I think we'll see severe warnings all through these lines, and then I think we'll see mostly flood warnings. You'll see wind damage. Let me go back and look at get rid of that. Like I said, that pressure gradient. We already got 20 knot winds, 25 knot winds from the south. We had that low level jet. Let's go pull up the 850 real quick. Let's see what we have for wind speeds at the 850. $50 winds on a low-level jet, $40 winds low-level jet in Georgia. I can get more station plots on this thing too. So we got any plots in Mississippi if the lane balloons go wherever we go. 50 knots all the way from Louisiana, Mississippi, and all the way up into Tennessee. So we have a pretty good low-level jet. So pretty much look for those drop to the surface. We do have a rotation right here. We got winds out of the northwest, winds out of the south. So we have an upper front. That's justifying that frontal system dropping back into Texas right there. And then these winds could drop down to the surface with these thunderstorms. You get a down burst from the downdraft from the thunderstorms. Bring that wind to the surface, and you can get some pretty good gusts out of those thunderstorms, do some damage. So alright, I think I'm going to go ahead and end this video for now. We'll possibly go live here shortly. Thanks for watching, and visit my website, meteorology101.com, and get your head in the clouds to learn about some weather.